Hello and welcome to the second video of Kafka with Spring Boot series. In this video we are going to talk about Kafka replication, partitions, and also consumer groups. I started with replication, but I'm not actually sure if we'll have enough time to go over replication, but we'll see. This video is going to be built on top of the first video that we took, so if you didn't already watch it, please go and have a look at it because we are going to be using the same project over there. And if you don't want to spend 30 minutes of your time trying to rebuild that project from scratch, there is a GitHub repository down below in the description section, a link to the GitHub repository. So you can check out the project from there and start that way. So that said, let's not lose any time and jump into it. This time I'm planning to start with some theory because we need to understand how Kafka works internally to understand the topic of this video. So if you remember, in our first video we deployed or installed a Kafka instance onto our local machine. So this is our Kafka instance that we installed. And we also built a simple Spring Boot application. And we had a producer in that application which writes messages to this Kafka this way, right? And also we had a consumer on the other side. Let's say C to this one, and it was consuming messages from Kafka. And if you again remember, this producer was actually writing these messages to a Kafka topic. Let's show a topic like this. In our video, this topic was called Kafka tutorial, but here I'm going to say or call it T1, topic 1. So this is where we left off at the end of our first video. To understand what we are doing on this video, we need to look into the details of what a topic is a little bit. Not too deep, but we just need to understand it a bit better. So let's say this is my topic, T1. Excuse my drawing, by the way. So this is topic 1. And a topic actually internally consists of one or more than one partitions. So, and let's show them like small topics over here. Let's call this one a P. So this is a partition. You can think of a partition as a subtopic. So this topic basically distributes all the incoming messages that is sent to it into these partitions. When you are writing a Spring Boot application, you don't have to know about these partitions if you are if you're writing a pretty basic application. But if you want to do some more advanced stuff, if you want to have multiple consumers and all that, we'll go into that in a minute, you have to know about this. So on the left hand side of the equation, if you remember, okay, we have our producer, and we said this producer is publishing messages to this topic, and whatever message is published, it's being distributed onto these partitions by the topic, or by Kafka actually. So we also said a topic can have more than one partition. In the example we had in the first video, the topic we created had only a single partition because that's the default behavior. When you create a new topic with Kafka, if you don't explicitly tell how many partitions you want it to have, Kafka and actually Spring Boot also will default to a single partition. But we could have multiple partitions. So let's call this partition 1 and call this partition 2. And assume this producer is sending messages over here. Let's call them M1, message 1, message 2, message 3, message 4. Doesn't matter how many messages you have. So the producer sends these messages onto this topic, and then we said this topic, or Kafka, distributes these messages onto the partitions. So in this case, it might go like this. Message 1 and message 3 might end up on partition 1, and message 2 and message 4 might end up on partition 2. So why do we need to understand about these partitions, or why am I telling you? Is because on this side of the equation this time, we have our consumers. So in our example, in the first video, we had a single consumer and we had a single partition, and the partitions, when a consumer subscribes to a topic, these partitions are actually assigned to the consumers. So in the first video, again, our consumers subscribed to this topic, Kafka tutorial topic, and we only had a single partition, which is this, and it gets assigned to this consumer. So in this case, all the messages, because if you remember, we didn't have the second partition in the first video, so we had a single partition. Let's don't see it for now. This P2 doesn't exist. So all the messages M1, M2, M3, M4 would go on to this partition 1. So these M2 and M4 would be also here. So that means they are actually being delivered to the same consumer. All the messages we sent onto this topic would be, or was being delivered to this consumer 1. But think about a scenario that you want to have multiple consumers. So let's call this one C1, and now I want to have another consumer here which also wants to subscribe to the same topic and wants to receive these messages and process them. So why would you need multiple consumers on this site? I can think of a couple of reasons. One of them might be HA, which is high availability, so that whenever this one dies, you have a second consumer which continues to process your messages. So your application is more resilient and you have redundancy. This might be a reason that you might want multiple consumers here. But another reason, and in this case, usually this takes priority over HA, is parallelization. Right? You want to parallelize your work. So this producer sends 4 messages. You want to have more consumers on this site so that you can process those messages faster. I mean, assume a scenario where a producer produces messages much more faster than a single consumer can handle. In that kind of a scenario, you can add a second consumer so they can catch up, or a third consumer, fourth consumer, so that they can catch up to the messages that are being sent to the topic by this producer. So when you add a second consumer, before we go there, there is a rule in Kafka that says one partition can be assigned to a single consumer. So if you have only one partition over here, partition 1, when you have 2 consumers, this partition will be assigned to C1. Which means if you have a single partition, you can't have parallelization. If you want parallelization, you need to add a second partition to your topic, so the messages that are ending on this partition 2 will end up on your second consumer, because this partition will be assigned to that consumer now. And Kafka handles all these partitions assignments automatically, so that's not something that you need to deal with unless you want to go advanced configuration and want to say, okay, I want this partition to be specifically handled by this consumer. If you don't have that kind of a use case, you can just let Kafka manage it for you. And by manage it, what I mean is, assume a use case that you have two partitions over here and you have a single consumer. Let's forget about this one now for a second. Let's forget about these parts. Kafka will actually automatically go and assign both of the partitions to the same consumer 1, because you only have one, which means that none of your messages actually got stuck on a partition. I mean, all of them are going to be handled by the single consumer. But in the scenario that you decide to add a second consumer over here, consumer 2, Kafka will recognize this and go and do a reassignment and move this partition to the new consumer. So in that kind of a scenario, assume you get new messages here, M5, two new messages, M6, and M5 might end up over here. Oops, I didn't like how this thing looks now. Let's M5, let's try it again. M5 will end up over here, and M6 will end up on our partition 2, which means M6 will be delivered to consumer 2 because that partition is assigned to the second consumer, and M5 will be delivered to consumer 1. So you're effectively distributing the incoming work onto multiple consumers, so you probably have a much more faster system. So in the future, if you want to make it faster and faster, what you can do is you can add a consumer 3, but what you need is another partition, right? So that it can get assigned a partition as well. So you just go and add partition 3 here, and Kafka will start distributing the work onto partition 3 as well. Okay, I think we are at a good state. Let's go and look at the code a little bit and try to understand how these things comes to life. So where is my IntelliJ? Okay, come back up. So this is where we left off at the end of our previous video, but what I discovered is the Kafka image that I used in the first video seems to be an old one, and it was not compatible with Spring Boot. So I found a new way, or a new image, and a better way of deployment for that image. So to do that, you need this docker compose.yaml file, and this file is going to be included in the GitHub repository that I'm sharing the link for. And I don't want to go into the details of what's in this file, but basically this is defining our images, how are going to be interacting with each other, and all that stuff. But to get it running in your local Docker, all you'll have to do is go into the directory that file sits in, docker compose.yaml, and just do a docker compose up and -d. So you are basically saying bring up whatever is defined in this file, and -d means run it in detached mode, so it's not going to be blocking your terminal. So let's see it running, and when it's booting up, let's look into our kitematic. Okay, Yes, so they are booting up. We have a Kafka instance and we have a Zookeeper instance. Kafka is still booting up, so let's give it some time. It seems to be a little bit slow. Yeah. Now it's moving. I think it was waiting for Zookeeper. Okay, our Kafka instance is up. Let's go back and look into our code now. And if you remember, we had a controller class which we had defined a single RESTful endpoint which was taking a message as a parameter, and it was sending it to a Kafka tutorial topic, and it was using this Kafka template to communicate with Kafka. And also we had defined a listener for the same topic, and the only thing we were doing was logging the incoming messages. But before we go into this video's coding, let's go and make some cleanup here. I want to do some refactoring. I want to do some separation of concerns, move stuff to their own classes, all that, so we can have a cleaner code base. The project might grow in the future. I don't want to end up in a mess. So let's call one of our classes Kafka Consumer. Add it to the Git repository and call our second class the Kafka Producer. Also add that to our Git repository. And what we are going to do is we are going to move this listen method, because this is the consumer logic, to our Kafka Consumer class. So now it will listen those messages over there, and we will move the producer related logic, which is this line, to the producer. And to be able to move it, let's create a new method, public void send message to topic. Let's call it send message to topic, and it's going to take the message as a parameter. And also let's pass the topic name this time as well. It might come handy. And we're going to paste this over here. Instead of giving the topic name statically, we are going to pass the topic name as a parameter now. Oh, it's complaining about our Kafka template because we didn't move our Kafka template definition over there. I don't need the Kafka template in the controller anymore because it's this producer's responsibility. And let's make this a bit cleaner. So I have a private final Kafka template, and I want to include a constructor as well. Okay, so that I can auto-wire it over here. Alright, so I auto-wired my Kafka template, and I'm using it to send a message to the topic that I'm passing in as a parameter. Let's go back to our controller. I don't need this constructor anymore. Good. And now, oh, I actually needed that constructor. Anyway, so I need to have my private final Kafka producer over here, right? Because now this controller is going to make a call to the method that I defined in there. So this again needs a constructor. Let's pass it in and call it AutoWire. Alright, everything seems good. Now I need to make a call to this Kafka producer. That sends message. This is the new method that I created. I am sending the message. I also need to send the topic, but I don't have a topic, so let's add it as a parameter. Let's go and define our parameter over here. It's called string topic, and it's also a request param. So when I'm making a request to this endpoint, I can actually say which topic I want the message to end up. So if I go to the Kafka consumer, this is also complaining about this log statement because I didn't include this SLF4J annotation. And if you want to know what this is, look into the first video, please. That's basically a Lombok annotation that cleans up your code base from boilerplate code. And the last thing that we need to do is make these producer and consumer classes Spring Beans so that we can auto-wire them around. And Spring also will find out about this Kafka listener annotation over here. So I need to do the same thing to the producer. Spring has many different bean defining annotations. Component is one of them, service is another, repository is another. So in this case, components is just enough. And let's go and start our application now to check if it's still working. While it's booting up, let me do some cleanup. There's some stuff I left there when I was preparing for this video. So our application is booting up. It's seeming to have some problems, but it's doing the assignments over here on the Kafka side, so I think it's going to be okay. Yeah, so it's up, and if we look here, we were actually talking about those partitions, remember? And I said by default Kafka will create a single partition for the topic that you defined, and in our case we really have a single partition. We can look at the logs here and we can see the partitions assigned to this consumer is Kafka tutorial 0. So there is a single partition. So Kafka names these partitions by the topic name dash an index, and it starts with 0. So if you have three partitions, it will go like Kafka tutorial 0, 1, 2, whatever. So in this case, we know that there is only a single partition here. So let's go and send a message to this endpoint, and where's my scratches? It's here. I know my topic is called Kafka tutorial, so I have to send my messages to this Kafka tutorial topic, and this is the new parameter I added. It's called topic, and I want to send this message, and the message contains say tutorial 1. So let's make this call. We should see in our logs that it arrives to our application. Yeah, this is coming from the controller, and actually this message is coming from Kafka. So this is coming from my consumer class because it's the one that's listening for these incoming messages. And now, actually I don't want to do that. Okay, that's fine. Now let's go and try to bring up our second instance, because now we are going to look into when we bring up this, what happens, what does Kafka do. So the easiest way to do this in IntelliJ is actually go and create a new configuration over here. We want it to be a Spring Boot configuration, so go and pick Spring Boot, give it a beautiful name, Kafka tutorial. Let's call this instance 2. I have to pick my main class, and also I have to change my port because this is a web application that uses Tomcat, and my first instance is already using the default port, which is 8080. So let's give this a 1991. I need to change the port so it will come up, otherwise it's going to complain saying this port is already in use. So let's click OK. Let's start our second instance. Basically, it's the same application. It's attaching or subscribing to the same topic. So we didn't change anything. We are just starting a second instance. The only change is the port that we are running it on. So it comes up. So it's booting up. Now it's starting at port 9091. Hopefully we are going to see it over here as well. It's going and being attached to the same partition. I'm sorry, it's being attached to the same topic. But if you see over here, Kafka did something interesting. If you see, it just went and assigned my only partition, Kafka tutorial 0, to my new instance, instance 2, and it revoked the partition from my first instance. So no partitions are assigned to this one now. So if you see, I mean, this doesn't always work like that. It could have left the partition on the first instance as well. I mean, this is Kafka magic. You don't have to think about how it works or why it does it that way. But what I'm trying to show here is a partition is just staying on a single instance. So if you have multiple consumers and a single partition, only one of them will be assigned a partition. So let's go and run some more tests and send another message. Tutorial 2. Go check our logs again. And in my first instance, I don't expect to see the message. I'm seeing this log over here, but this is actually the log coming from the controller, not from the listener. So this message, tutorial 2 message, didn't arrive into this consumer from Kafka. This log is coming from here, from the controller. So this is not related to Kafka. But if I look into my instance 2, yeah, this is the log I'm looking for. Message coming from Kafka tutorial 2, and it exists on my instance 2. So if I send the third one, I'm expecting it to arrive onto instance 2 as well. And as you can see, tutorial 3 arrived onto instance 2, and instance 1 still doesn't get any messages. So we said we want to go and do parallelization. Now we have HA actually. I mean, we have high availability. Even our first instance is not handling any messages. If your second instance goes down, Kafka will automatically assign that partition to the first instance, so your application can continue to process messages. So it's the application doesn't go down as a whole. You have HA. But what we don't have is parallelization. So we said to be able to have parallelization, you need to create another partition. So you need to increase your partition count on the topic. And Spring makes this very easy for you. So let's create a new class and call this Kafka topic configuration. You can name it anything. In this case, this makes sense to me. And this is a configuration class, so we are going to create Spring Beans in this. That's why let's go and annotate it with a configuration annotation. And the next thing we have to do is create a topic, a new topic, and somehow make it have more than one partition. So 2 partitions. So for this, Spring gives you this new topic class, which is very handy to create topics or configure topics. And let's call this topic the Fatih topic. That's the easiest thing that I could think of. So basically you are creating a method here, or we are creating a Spring Bean. And oh, I have a typo. Let's go and fix that. This is Fatih topic. Fatih is my name, by the way. Nice to meet you. And to create that new topic instance, Kafka also, not H, Kafka also gives you this topic builder class to make things simpler and easier. not Kafka, I'm sorry, Spring Boot gives it to you. And in this one, we are going to use the name, and our name, so this is the name of the topic. We said it's going to be Fatih topic. And another method that this provides is these partitions. So it takes an integer as a parameter, which is partition count, basically. So if we want to have 2 partitions for this topic, let's go and give it 2 partitions. This is the builder pattern. So if you don't know about it, go and have a look and Google it, saying what's the builder pattern. It's a pretty beautiful and handy pattern. So we basically created our topic, but what we forgot is I said we need to make this a Spring Bean. So to do that, let's go and annotate with a bean annotation. So this is all we have to do to create a new topic and configure its partitions. So on this topic builder, there are other methods like assign replicas, compact, config, whatever. There are a lot of methods here that you can fine-tune and make different configurations when you are creating your topics on Kafka, but they are not, I'm not going to cover them in this video. That's too much. And I don't know, but this thing is somehow complaining. Oh, we forgot our return statement. Okay, so we created our topic. Now what we need to do is, of course, write to this topic or read from this topic, right? We never did anything like that. So to be able to write to the topic, actually we don't have to change much because this producer is kind of generic now. I'm passing it the topic name and it will send my message to that topic. So that's pretty cool. But to be able to consume those messages, I have to go and make some changes over here and say, I now want to listen this new topic, which is called Fatih topic. And let's call this message listen, not message, this method listen Fatih topic. Yeah, so that I can start listening the messages coming from there as well. And to differentiate these 2 logs from each other, it's okay. Let's put some topic related information into this log. So this topic is called Kafka tutorial. Okay, and let's copy that. And this topic is called Fatih topic. Oh, I'm sorry. Yes. So that's all that we need to do. We created our listener for the new topic. We created our topic. And yeah, actually, that's really all. Let's go and stop these 2 running instances. And don't forget, we configured our new topic, which is called Fatih topic, to have 2 partitions now. So let's go and start our first instance again. So it's booting up. Okay, still booting up. Okay, so let's check what's going on over here. So this is my first topic, which was called Kafka tutorial. It still has a single partition and that's assigned to this consumer because currently I have a single consumer. And let's look at over here. So now I have a second topic, which is called Fatih topic. This time it has 2 partitions and both of the partitions is assigned to this consumer. Again, because we have a single consumer and Kafka knows about this and assigns all the partitions to this consumer. But if I had a second consumer, what I'm expecting is for Kafka to move one of those partitions to my second consumer, and let's go and try to see if that works really that way. So I'm bringing up my second instance. I'm expecting the Kafka to get one of those partitions from consumer or instance 1 and move it to the new instance that's coming up right now. And it's only going to do it for the second topic, which is Fatih topic, because my Kafka tutorial topic has only a single partition, so it's going to remain on one of those instances. So the application started up. Let's look what happened over here. And if you can see, it revoked, no, not this one. Where is that? Where are you? Yeah, it revoked both of the partitions, Fatih 1 and Fatih 0, from my first instance, because they were assigned over here. And then it went and reassigned Fatih topic 1 onto this one. And if I go and check my second instance, Fatih 0 is assigned to this one. So basically what I did is, I now have parallelization, right? Kafka assigned one of the partitions to my first instance and the second one to my second instance. And if I go and start sending messages to these endpoints now, let's call this tutorial 4. And if I send it, let's send the 5. Oh, what I'm doing wrong is I'm sending them to the wrong topic. So I need to change this to Fatih topic. I was sending them to the first topic that we had created in the previous video. So let's send 2 more, 6 and 7 and send an 8. Why not? Right, just send them. Send a 9. And let's go and check our logs now. So in my first instance, which is called Kafka tutorial, if I check over here, yeah, so here are the messages that arrived. One of them is called topic Fatih topic, or the logging, and tutorial 6 and 8 arrived to my instance 1. And if I go to my instance 2, 7 and 9 arrived to my instance 2. So this is what I was expecting. I sent 4 messages, 2 of them arrived to one instance, 2 of them arrived to another instance, which means I have parallelization in place. So this is what our partitions use for. That's why what you have to know about partitions while you are designing your applications, because otherwise you can't have these kind of parallelization in place. And one thing to remind or keep in mind is you can grow the partition count of an existing topic. Say you started with a single partition, you can go and change your configuration, make it have 2 partitions, 3 partitions, 4 partitions, 5 partitions. But if you want to go back down, that's not possible. So if you had 5 partitions and if you want to go to 2 partitions, Kafka is going to say, no, you can't do that. There are workarounds to handle that. One of them is like create a new topic, go and move all the data, write a small script or a program that moves the data that exists in the first topic and move it on to the new topic. And then, have the number of partitions that you want and then go and delete the old topic so that you can go and rename your first topic again, whatever. So, but there are some, as I said, there are some workarounds. But normally Kafka doesn't let you do that. So plan ahead and don't start with a very big partition count that you might want to bring down in the future. Okay, so we talked about one of the scenarios that I wanted to cover. But the next thing that I want to talk about is, so in this example over here, we have 3 consumers, and now I want to add another consumer here, and let's call that consumer C4. This is my 4th consumer. But what I want to do is I actually want all the messages that are being delivered to my consumer C1, C2, C3, whatever, so that are ending on these partitions to be delivered to the C4 as well. So because if a message is sent to partition 1, we said a partition can only be assigned to a single consumer, and it ends up on this consumer. But if a partition can be assigned only to a single consumer, and if I want to same messages to be sent to over here, basically what I'm saying is actually I want this partition to be assigned to this new consumer as well. But this is against the rule that I define. And to describe this, we need to enhance the rule, right? We are going to enhance the rule by saying a partition can be assigned to a single consumer in the same consumer group. So what's a consumer group? A consumer group is a logical construct that wraps a set of consumers, and let's call it this one consumer group 1, CG1. And I can create a second consumer group and call it CG2. So what I said was a partition can only be assigned to a single consumer within the same consumer group. So if I have another consumer group, actually that partition will be assigned to the consumer in this consumer group as well. So this is how you can have scenarios like you're broadcasting to multiple endpoints. So this is not just for queuing and message processing, but this is for messaging multiple systems saying that something happened, because multiple different systems doing different things with your messages might have subscribed to your topic, and they might be expecting the message. In that kind of a scenario, this is what you have to do. You need to create multiple consumer groups and put these different types of consumers into different groups, so all of them can get the incoming messages from the same topic and be assigned to partitions. And because in the consumer group 2 I only have a single consumer, actually what Kafka is going to do is it's going to go and assign all of these partitions to the same consumer. So all the messages that arrives onto topic 1, which is being distributed to 3 partitions, will be delivered to C4 as well in consumer group 2. So I hope this is clear. If it's not, please put some questions in the comment section, and let's go and try to see how we can work with these consumer groups. And if you remember from the first video, I had talked about 2 parameters in this application YAML configuration file that we had put into our project, and one of them is, as you can guess, Kafka consumer group ID. So basically Spring Boot gives you this easy configuration to define the consumer group of your application, and in this case our application belongs to the Kafka tutorial consumer group. So I have 2 instances that are running right now, and both of them are belonging to the same Kafka tutorial consumer group because I brought up them with the same configuration. But if I want to have a different consumer group and want to bring up another application with the new consumer group, what I can do over here is actually I can go and create a new profile, right? Spring Profiles comes in handy in these kind of scenarios. So, and I want to call it Spring.Profiles active. So basically what you are saying is when this application is running in this profile, and let's call this profile consumer group 2, I want it to run with Spring Kafka, not Lafla, Kafka dot consumer group ID, and I want to give it a different group ID, which is going to be, let's call it Kafka tutorial 2. Now I want to have a new application that's going to be running with this configuration, and to do that I need to go and add a new application configuration here. I will go and I'll go and pick Spring Boot type and give it a good name again, and we're going to call it Kafka tutorial. Let's call this one CG2, consumer group 2. Our main class is the same main class. I want to run it on a different port because my first application is already using 9091, and I want to make this run with the profile CG2. So this active profile section in your application configuration lets you define with which profile you want your application to boot up with. And if we apply this, basically it's matching this CG2. So my new instance is going to pick up this configuration. If you don't have a profile definition in your configuration file, like in this case, this is the default configuration, so it will be applied to all the applications that you start with this application YAML file. But if you pass the CG2, whatever you have over here will go and override the values from the default configuration. So let's go and start this new CG2 application. I'm actually bringing up my third instance over here. And when it's booting up, let's think about what we are expecting, right? Let you think about it. So what we are expecting is we have two topics. I want this application to go and subscribe to both of the topics because it has all the same configuration, all the same listeners and producers, whatever. And did we have a problem? Yeah, we seem to have a problem. Oh, but somehow, oh yeah, 1992 seems to be in use. Let's go and change that port to something different. Let's make it 9191. I hope this one is not in use. So let's go restart this instance and go back to our discussion. So I'm bringing up a new instance, as I said. It has the same configuration, same implementation. I'm expecting this one to go and subscribe to the same topics, which are Kafka tutorial and Fatih topic. And because there's a single instance in my new CG2 group, consumer group, I am actually expecting this one to be assigned all the partitions in those topics. So if we check our logs, yes, this one went and subscribed to my Kafka tutorial topic, and it got the only partition that it has, and it also went and subscribed to Fatih topic and got both of the partitions assigned to itself. So let's go and run some tests again, and what we are expecting now is when I send a message, a new message, I'm expecting this message to appear on one of these two instances because they belong to the same consumer group, and I also expect it to appear on the second consumer group, so on this instance as well. So let's go and make our call. Our call is successful, and let's check our logs. I sent tutorial 10, so yes, it arrived onto this instance. It's not going to arrive on this one because that partition is not assigned to this guy, so it is still sitting on tutorial 9. And if I look into the instance that I'm running in my second consumer group, yes, I see the tutorial 10 message in this one as well. So this is the second type of scenario that you can have in your applications. And with this, I think we did enough talking for this video. I was planning to talk about replication as well, but we don't have enough time. Let's do it in our next video. And as I said at the beginning, there is a links to the GitHub repository for you to go and check out this project. I'm creating separate branches for each state, meaning at the end of every video or each video, I'm creating a new branch, so you can follow up and check out a different state and continue it that way. So if you are working on the third video, go and check out the second branch. They are named accordingly, and start working that way. If you have any questions, any comments about the quality of the content, video, audio, whatever, please put some comments down there. And if you like this, the videos, go and subscribe. And with that, I think we are at the end of our video. If you made it up to this point, thank you very much. If you couldn't, that's okay as well. And I think that's all. Fatih out.